Hello friends, a very good morning to all the students. Am I audible to all? Okay, fine. Thank you all for your responses in the chat box. So friends, you are aware that since last few lectures, we are discussing the important chapter that is the fifth unit of basic mechanical engineering. The chapter name that is the heat engines. And friends, in the last lecture, if you remember, we have discussed the theoretical and the analytical aspects of the diesel cycle. So let me ask you one of the simple question related to the topics which we have discussed in the last lecture. What is the another name of the diesel cycle? What is the another name of the diesel cycle? Very good. I am getting the good responses and the perfect answers from majority of the students in the chat box. The perfect answer, the another name of the diesel cycle, that is the constant pressure cycle. Because in the diesel cycle we have understood the heat addition takes place at the constant pressure conditions. And friends, as informed in the last lecture, in today's lecture, we are going to solve the numericals of the diesel cycle. So, are you all ready with the scientific calculator, with the notebook, with the pen and other stationery that is required for solving the numericals of the diesel cycle? Okay, fine. So getting your responses in the chat box that you all are ready for solving the numericals of the diesel cycle. So before proceeding to the numericals, first let us remember and let us note down some of the equations which will be useful for solving the numericals of the diesel cycle. Remember friends, for the diesel cycle also, as we have done in the auto cycle, first and foremost thing, we need to draw the PV diagram and the TS diagram before starting the numerical. So this is the PV diagram and the TS diagram representing the different processes of the diesel cycle. Now let us understand some of the equations which will be used for solving the numericals. The first equation, that is the compression ratio. In other terms, it is also known as the volume ratio. So it is given as small r is equal to Vc plus Vs divided by Vc, where Vc stands for the clearance volume, Vs stands for the stroke volume or the swept volume. Now from the PV diagram of the diesel cycle, we can find out that Vc plus Vs, that is equal to total volume, that is V1, and Vc is equal to V2. So substituting these values, finally we can write down compression ratio R is equal to V1 by V2. Next, the important ratio in context of the diesel cycle, that is the cut-off ratio. If you remember friends, for the cut-off ratio, I am using the notation that is RC. You can use the notation rho also, because the rho is given in your textbook. So RC is equal to V3 by V2. Next, the expansion ratio, that is V4 by V3. And in the equation for the efficiency of the diesel cycle, we have calculated V4 by V3 is equal to R by RC. I hope you are remembering this equation. Let us proceed further. Now for the adiabatic, that is reversible adiabatic, isentropic compression process, that is process 1 to 2. Writing down the equations for the adiabatic process, that is P2 by P1 is equal to V1 by V2 raised to gamma. So that is R raised to gamma. Similarly, T2 by T1 is equal to V1 by V2 raised to gamma minus 1. Again, V1 by V2 is equal to R. So answer becomes R raised to gamma minus 1. Moving further, similarly for the reversible adiabatic or the isentropic expansion process, that is process 3 to 4, we can write down these equations. P3 by P4 is equal to V4 by V3 raised to gamma, and we have already understood that V4 by V3, that is equal to R by RC, and T3 by T4 is equal to V4 by V3 raised to gamma minus 1. So that is also equal to R by RC raised to gamma minus 1. Dear students, are you understanding these equations? Are you noting down these equations? Because this will be very useful in solving the numericals. I want your responses in the chat box so that I can proceed further. Okay, thank you all. Majority of the students have responded me in the chat box that they are noting down these equations and also they are remembering the equations. Let us proceed further. Now for the constant pressure heat addition process, that is process 2 to 3. I can write down the Charles law because the pressure remains constant. So on the basis of the Charles law, we have written this equation V2 by V3 is equal to T2 by T3 because the pressure remains constant, that is P2 is equal to P3. The amount of heat supplied during the constant pressure process, that is process 2 to 3, is Q in is equal to Cp T3 minus T2. Remember friends, the mass of the working fluid, that is air, we have considered it to be 1 kg. So I have not mentioned the term mass in this equation. Similarly, for the constant volume heat rejection process, that is process 4 to 1. Since the volume remains constant, I can write down this equation, that is P4 by P1 is equal to T4 by T1 because the volume V4 is equal to V1. Now the amount of heat rejected during the constant volume process, that is process 4 to 1, is Q out is equal to Cv, the higher temperature minus the lower temperature, so that is T4 minus T1. Now the air standard efficiency of the diesel cycle is given as eta diesel is equal to net work done divided by heat supply. So that is W net upon Q in. W net is equal to Q in minus Q out. Substituting these values, cancelling the common terms. If you remember, we were getting these answer. Eta diesel is equal to 1 minus T4 minus T1 divided by gamma T3 minus T2, where gamma is always constant, that is 1.4. So this is the equation for efficiency in terms of temperature. And after the calculations, after the derivations, we have got this final answer. So eta diesel is equal to 1 minus 1 upon R raised to gamma minus 1. RC raised to gamma minus 1 divided by gamma into RC minus 1. If you are referring your textbook, then in place of RC, you will be observing the notation that is rho. and the rho stands for the cut-off ratio. Is it clear to all the students? Have you written all these equations? Kindly give me your confirmation so that we can move further in solving the numericals. Okay, thank you dear students for your response. So now let us proceed further and solve the first numerical. The first numerical is given that in an ideal diesel cycle, the temperature at the beginning and at the end of the compression are 57 degrees Celsius and 603 degrees Celsius respectively. The temperatures at the beginning and at the end of the expansion are given 1950 degrees Celsius and 870 degrees Celsius respectively. Determine the ideal efficiency of the cycle if the pressure at the beginning is 1 bar. Also calculate the maximum pressure in the cycle. This numerical was asked in the GTU examination for the 7 marks. So in the solution, if you remember, first you need to draw the PV diagram and the TS diagrams so that you can understand the data which are given in the numerical. So as per our practice of the presentation, firstly we are writing down the solution. Then the first step, that is step number 1, given data. So the first data which is given, that is an ideal diesel cycle. The temperature of the air at the beginning of compression is given, that is T1 57 degrees Celsius. Converting this temperature into Kelvin. Then we are given the temperature at the end of compression, that is T2 603 degrees Celsius. Then moving further, we are given the temperature at the beginning of expansion. Remember friends, the expansion process is starting at point 3. If you understand the PV diagram perfectly, I hope that you are understanding the given data. So T3 is given 1950 degrees Celsius. Similarly, the temperature at the end of expansion, that is T4, is equal to 870 degrees Celsius, converting all the temperatures into Kelvin. Also, we are given the pressure at the beginning of compression, that is P1 is equal to 1 bar. So, the bar is converted into Pascal. Step number 2, that is to find. First, we need to find the ideal efficiency of the cycle, that is eta diesel. And then we need to calculate the maximum pressure in the cycle, that is P3. Dear students, have you understood the given data and to find perfectly? Shall I proceed further with the third step of the calculations? Kindly give me your confirmation so that I can move further. Okay, fine. So let us proceed further with the calculations. Step number 3. So firstly, the air standard efficiency of the diesel cycle is given as eta diesel is equal to 1 minus T4 minus T1 upon gamma T3 minus T2. Now you will be asking, sir, why you are using this equation in order to calculate eta diesel? Because in the given data, I have been given all the 4 temperatures. I am having the value of T1, T2, T3 and T4. And gamma we are already knowing that is constant. So I can directly use this equation, that is 1 minus T4 minus T1 upon gamma T3 minus T2. Substituting these values, we are getting the answer eta diesel is equal to 0.57. Remember friends, the efficiency always needs to be converted into percentage and that must be in the round figure. So the first answer which we are getting, the air standard efficiency of the diesel cycle, eta diesel is equal to 57%. Let us proceed further. This was very easy to calculate eta diesel. So now we need to calculate the maximum pressure attained in the cycle. So for that particular parameter, I am taking the isentropic adiabatic compression process, that is process 1 to 2. We know that T2 by T1 is equal to V1 by V2 raised to gamma minus 1. V1 by V2 is equal to R, so that is R raised to gamma minus 1. So using this equation, firstly I am calculating the compression ratio. So compression ratio, the answer comes out to be 11.48. So this is the answer of the compression ratio. Now friends, using the same process, that is the adiabatic compression process 1 to 2, we know that for the adiabatic process, PV raised to gamma is equal to constant. Therefore, P1 V1 raised to gamma is equal to P2 V2 raised to gamma. So I will be calculating the value of P2. So P2 is equal to P1 into V1 by V2 raised to gamma. So P1 into R raised to gamma. We are already knowing the value of P1. We have calculated the value of compression ratio R. So my answer of P2 comes out to be 30.47 into 10 raised to power 5 Pascal. So this value can be converted into bar. So that is 30.47 bar. Now friends, if you understand the PV diagram, any student can give me the answer. What will be the maximum pressure attained in the cycle? What is the maximum pressure attained in the cycle? If you understand the PV diagram, what will be the answer? Any student? Very good. I am getting some of the responses from the students. That is the perfect answer which I was expecting from the good students, from the intelligent students. Perfect understanding of the diesel cycle and the processes of the diesel cycle. So the same thing now I will be mentioning in my further step of the calculation. So thus from the PV diagram for process 2 to 3, the pressure remains constant. So I can write down the maximum pressure, that is P3 is equal to P2, that is 30.47 bar. And this is the value which was asked to calculate. So my final answer, the maximum pressure attained in the cycle, that is P3 is equal to 30.47 bar. Dear students, have you understood this numerical perfectly? Are you getting all these answers perfectly? Okay, fine. Thank you all for again the positive responses in the chat. So now let us proceed further and solve another type of the numerical in context of the diesel cycle. An engine operating on the ideal diesel cycle has the maximum pressure of 45 bar and maximum temperature of 1500 degrees Celsius. The pressure and temperature of air at the beginning of compression stroke are 1 bar and 27 degrees Celsius respectively. Find the air standard efficiency of the cycle. Assume gamma that is equal to 1.4. So step number 1, that is the given data. So firstly we are given that the engine is operating on an ideal diesel cycle. So I have mentioned it as the ideal diesel cycle. The maximum pressure in the last numerical, the same concept we have calculated in this numerical, we have been given that particular point. So maximum pressure attained in the cycle, that is P3, but according to the PV diagram I can write down P3 is equal to P2, that is equal to 45 bar, converting that into Pascal. And if we consider the TS diagram, you will observe the maximum temperature is attained at point 3. So maximum temperature attained in the cycle, that is T3 is equal to 1500 degrees Celsius, converting this temperature into Kelvin. Then we are given the pressure of the air at the beginning of compression, that is P1 is equal to 1 bar. And similarly, the temperature of the air at the beginning of compression, that is T1, is equal to 27 degrees Celsius. And we are given gamma is equal to 1.4. Step number 2, that is to find what we need to calculate in this numerical. We need to calculate the air standard efficiency of the cycle. That is, we need to calculate eta diesel. Dear students, have you understood both these steps, the given data as well as to find? How I am presenting the steps, how we are converting the values. Okay, thank you all once again for the response. Let us proceed further and start the important step, that is the calculations. Firstly, we are considering the isentropic adiabatic compression process, that is process 1 to 2. We know that the relation between temperature and pressure. So T2 by T1 is equal to P2 by P1 raised to gamma minus 1 divided by gamma. So we need to calculate the value of T2. So T2 is equal to T1 into P2 by P1 raised to gamma minus 1 divided by gamma. Substituting these values from the given data, I am getting the answer of T2, that is 890 Kelvin. Remember friends, for every numerical value, we need to compulsory mention its unit in the SI system. Now friends, again I am considering the isentropic adiabatic compression process, that is process 1 to 2. Using the relation of temperature and volume. So I am using the relation, that is T2 by T1 is equal to V1 by V2 raised to gamma minus 1. So V1 by V2 is equal to R, that is compression ratio. So thus calculating the value of R, so R is equal to T2 by T1 raised to 1 upon gamma minus 1. So the answer of compression ratio comes out to be 15.16. Let me know in the chat box if you are getting this answer of the compression ratio, or else let me know what is your answer you are getting after the calculation. Kindly share me your answers which you are getting, so that I can also cross check my answer with the answer of the students. Okay, very good. One student is getting somewhat the same answer near to my answer. Okay. Okay, that means you are taking the values. Fine. So I have got the answers. Okay. The same answers I am receiving from the students. Thank you all. So now let us proceed further with the calculation. Now for the constant pressure process, that is process 2 to 3. We know that we can apply the Charles law. So V by T is equal to constant. So I can write down V2 by T2 is equal to V3 by T3. So from this equation I can write down V3 by V2, that is equal to T3 by T2. I am already having the value of T3 and T2. Substituting that value, I am getting this answer V3 by V2, that is 1.992. And friends, we are knowing that V3 by V2, that is the cut-off ratio. So cut-off ratio denoted as RC. So RC is equal to 1.992. That is mine answer. Let me know your answers in the chat box. What is your answer of the cut-off ratio? Okay, some students are telling the same you are getting. Okay, some students have given me the answers in the numerical values. Okay, fine. That means your answers are matching with my answers. Okay, fine. So now friends, if you understand the calculations, we have calculated the compression ratio R and we have calculated the cutoff ratio RC. So now for finding out the air standard efficiency of the diesel cycle, we can directly use that bigger equation. So using that equation in the calculations, the equation is eta diesel is equal to 1 minus 1 upon R raised to gamma minus 1 multiplied by RC raised to gamma minus 1 divided by gamma into RC minus 1. We are having the value of compression ratio, we are having the value of cutoff ratio, gamma that is already given 1.4. Substitute these values in this equation. Kindly solve the equation perfectly in the scientific calculator, and after solving you will be getting these answer. The air standard efficiency of the diesel cycle, eta diesel, the final answer comes out to be approximately around 61%. Whenever you have completed the calculations from your side, kindly share your answers in percentage in the chat box. Always friends, remember the efficiency needs to be mentioned in the percentage, and that efficiency must be in the round figure. Okay, do not write down the efficiency in point wise. Convert that final answer into the round figure. Okay, very good. One student has given me the response that he is also getting the same answer which I am getting, that is 61%. Thank you. What about the other students? What are your answers? Kindly share me your answers in the chat box. Okay, one student has given me 60.8. So whenever we are approximating that value, that is approximately 61%. That is good, right answer. I want some more responses in the chat box of your answers. Okay, some student has given me the answer, that is perfect, 61%. Thank you. So I hope you have understood this numerical perfectly. Majority of the students are getting the same answers as I am getting the answer of the efficiency. Very good students. So now let us proceed further with the third numerical. In this numerical, the compression ratio of an oil engine working on the diesel cycle is 15. The cutoff takes place at 12% of the working stroke. This is a new statement which is coming into picture. Don't worry, I will be explaining this particular statement in the calculations. The air is drawn into the cylinder at 100 kilopascal and 27 degrees Celsius. Assume Cp 1.006 kilojoule per kg Kelvin and Cv 0.717 kilojoule per kg Kelvin. Calculate the temperature at the end of compression, the pressure at the end of compression, and the air standard efficiency. So starting with the solution, writing down the first step, that is the given data. Firstly, we are given the oil engine working on the diesel cycle. Then we are given the compression ratio, that is small r is equal to 15. Then we are given this important statement, cutoff is equal to 12% of the working stroke. Just mention this point right now. We will be understanding this concept later on in the third step of the calculations. The air is drawn into the cylinder. So the pressure and temperatures at point number 1 are given. So P1 100 kilopascal. Converting it into Pascal, temperature of the air T1, that is 27 degrees Celsius. Then we are given the value of Cp and Cv, specific heat at constant pressure and constant volumes respectively. Next, now we need to find the temperature at the end of compression. So compression is completed at point 2. So we need to calculate T2. Similarly, at the same point, we need to calculate the pressure P2. And finally, we need to calculate the air standard efficiency, that is the eta DC. Starting with the calculations, dear students, just remember that in this numerical, in the given data, we are given both the values of Cp and Cv. So in this numerical particularly, we can calculate the value of gamma. I am also knowing that the value of gamma will be coming 1.4, but calculating I will be getting some exact value of gamma. And next I will be using that answer of gamma in the further calculations. So understand this concept perfectly for this numerical. So firstly, we know that gamma is equal to Cp by Cv. We are getting the answer 1.403. Understood, students? Now in the further numerical, wherever the term gamma comes into picture, I will be using the value that is 1.403. So now considering the first process, that is the isentropic compression process, process 1 to 2, we know that T2 by T1 is equal to V2 by V1 by V2 raised to gamma minus 1. The relation between temperature and volume, and we are knowing V1 by V2, that is R. So substituting these values, I am getting the answer of T2, that is 893.48 Kelvin. So this is the first parameter I was asked to calculate, hence the temperature at the end of compression, that is T2 is equal to 893.48 Kelvin. So that is the first answer I have calculated. Moving further with the same process, that is the isentropic adiabatic compression process, process 1 to 2. P1 V1 raised to gamma is equal to P2 V2 raised to gamma. Pressure on one side, volume on another side. V1 by V2 is equal to R. So that is R raised to gamma. So calculating the value of P2. So I am getting the answer, that is 44.6 into 10 raised to power 5 Pascal. So that can be converted into bar. So hence the pressure of the air at the end of compression, that is P2 is equal to 44.6 bar. These two parameters are very easy to calculate. Now friends, the important step comes into picture in the calculations. So try to focus on the next steps which now I am explaining. In the given, we are already mentioned that cutoff takes place at 12% of the working stroke. And we are knowing that the cutoff takes place in the process, that is 2 to 3. The constant pressure process 2 to 3, the cutoff takes place. And the working stroke is considered as the stroke volume or the swept volume, that is Vs. So now understand how I am substituting these values for all these terms. So cutoff, for the cutoff, I am writing down that is V3 minus V2. Remember friends, it is not the cutoff ratio, only we are given the cutoff. So for that cutoff, I am using the final volume minus the initial volume, that is V3 minus V2. 12% is converted to 0.12 and working stroke, that is Vs, and equation for Vs, that is equal to V1 minus V2. Dear students, is this concept perfectly clear in your mind? This is a complicated parameter, complicated statement to understand. Have you understood this concept perfectly? Kindly share me your responses in the chat box. Okay, fine. Thank you all. Now I have responded. I am getting good responses from your side in the chat box. So now it is very easy to proceed further. Now what I will be doing in these equations, now in place of V1, I will be substituting 15 V2 because small r is equal to 15 compression ratio, that is V1 by V2. So V1 is equal to 15 V2. Calculating these equations, taking the term V3 on one side, V2 on another side, doing the mathematical calculations, rearranging the terms, finally I am getting the answer, that is V3 by V2 is equal to 2.68. And friends, we are knowing that V3 by V2, that is nothing but the cut-off ratio, that is RC. So I am writing down that particular value now for the cut-off ratio. So the cut-off ratio RC is equal to V3 by V2, that is 2.68. So now friends, we are having both these values of compression ratio R and RC. So now we can use our standard equation, the bigger equation for air standard efficiency for the diesel cycle, 1 minus 1 upon R raised to gamma minus 1 into RC raised to gamma minus 1 divided by gamma into RC minus 1. Now we will be substituting these values. Remember friends, gamma, we are taking the value 1.403 which we have calculated initially, and the final answer which we are getting, that is eta diesel is equal to 57%. Let me know your answers in the chat box after you are calculating the final answer. Kindly share me your answers in the chat box in terms of the percentage. How many students are getting this value? 57%, or what is your answer which you are getting? "42", that is not the answer. You need to calculate once again. That is the incorrect answer. 42 is not the correct answer. You need to check your calculations. You need to check the values which you have substituted in the equation. Any other student who is getting the answer near to my answer? Okay, fine. One student has responded. He is getting the same answer as mine answer. Okay, fine. So I am getting some good responses in the chat box that some of the students are getting these answers. That is very good. So this numerical is completed. Now friends, for your practice, I am giving you one numerical. So you just note down this numerical, and in the next lecture, we will be discussing the answers of this numerical. So this is the numerical for your practice. You need to calculate by yourself. In the next lecture, we are going to discuss the numerical, the answers of this numerical. So you can cross-check your answers. So friends, with this, we are completing the most important chapter, that was the heat engines. I hope you have understood the concepts of the heat engines perfectly. Thanks.